equations. So we're going to solve today log equations. So 7.5b, solve log equations. These are a little bit harder than yesterday's equations. Logs, okay? Yesterday's, those were exponential equations and we had to log both sides. Now we're going to do log equations where we kind of have to like take the exponential part of it. So let's start off with this. If you had log base 2 of 8 equals x. This is not really a log equation. I just want to see how you would solve this. If you're going to solve this, you're trying to find out what x is. How would you rewrite this or solve this in your mind? You would do what? 2 to the x equals 8. So x is 3. That's how you would solve this. You would evaluate log base 2 of 8 to go 2 to the x equals 8, so x is 3. That's what we're going to do for log equations. We're going to rewrite them so that they are in their exponential form, okay? So here you go. Here's your steps. Step number 1. You need to isolate the log. So once again, if there's a bunch of stuff around it, you want to get the stuff over to the other side, okay? Second thing you're going to do is if you have multiple logs, you want to combine your logs together using log properties. Those properties that we learned last week on Friday. Combine logs using properties. Sure, I would love to. If you have log base a of m plus log base a of n, do you remember what that is equal to? Sure. Log base a of mn. You multiply them together.
Log b.
Yeah, I just changed it. Yeah, as long as they're the same log base. If this was a minus in the middle, if you had log base a of m minus log base a of n, then you would divide m over n. That's to combine it into one single log. They're both log base a, but you want to get them together into one. And then the last one, which is the one that we use the most often, I think, is log base a m to the n, and that's equal to n times log base a of m. So there's only 3, okay? So you have to remember, addition of logs is putting them together is multiplication, subtracting is division, and a power to a power is multiplication. All right, and then, so you're going to isolate the logs, you're going to combine the logs using your log properties, and then you're also going to rewrite in exponential form. Okay, what makes this hard is that you're not really doing something to both sides. You know when you solve an equation, you square root both sides, or you log both sides, like yesterday. This is a little bit different, okay? All right, so I've got some examples for you. 1, 2, 3, 7-ish. Here we go. Number 1. Now, a reminder, when you're solving equations like this, you're going to write the problem down, and then you're going to solve. So here we go. Solve. Show work. Log 4x minus 3 equals 2. Okay? All right, so we're going to solve this equation for x. We're trying to figure out log of what would make that equal to 2. So what we're going to do is, first you want to isolate the log. Now this is already isolated. You cannot add 3 or divide 4. It's all inside the parentheses. It's being logged. So what you want to do is you want to now just skip to the last step. Rewrite this in exponential form. Okay? So how do you rewrite this in exponential form? Well, what is the base here? 10. So I'm going to rewrite this as 10 to the second, right? 10 to the second equals 4x minus 3. Well, you write it in its exponential form, right? A log is an exponent. 10 is the base, the exponent is 2, and it equals this stuff inside.
So it's like a rotation.
Yes, it is. And that's why I write the arrows there to help you out. 10 to the second equals 4x minus 3. And now you have this to solve. You got rid of the log by writing it in its exponential form. So what is 10 to the second? 100 equals 4x minus 3. The rest, you know, you're a pretty good algebra student by now. You could probably do the rest in your head. Add 3 and then divide by 4. You can leave it like that. You can round to, like, I don't know, 3 or 4 decimal places, whatever they want. This one, x is about 25.75. Okay? And if you're a little extra, you know, you can go back and you can check your work. I can actually plug it in. I can take the log of 4 times my answer minus 3, and that should equal 2. Yay! Checked it on my calculator. It works. All right, let's do some more. Number 2. Now, this one's going to look a lot like the last one. Log 4x minus 3 equals 2. Okay. This one, it's missing those parentheses. So really, it's the log of 4x and then minus 3 equals 2. So the first thing I need to do, anyone know?
Isolate the log.
Isolate the log. Perfect. Did you guys get that? Isolate the log. Add 3 to both sides. So you get the log of 4x is equal to 5. That's it for that first part. Now we need to solve for x, okay? So now we need to write this in its exponential form. Because people, this is where they get stuck. They stop here and they're like, how do I get rid of a log? You can't divide both sides by log. That doesn't make any sense. The way that you get rid of a log is the same way that you got rid of a log when you evaluated this. How'd you get rid of that log? You did in your head 2 to the what equals 8, and you got 3. That's what you did. You're going to do that same thing here. 10 to the 5th equals 4x. People get stuck there all the time, though. 10 is the base.
Is 10 always the base?
Yeah, it's not. It doesn't always have to be. There's one at the end that's not. But 10 to the 5th equals 4x. You get rid of the log by writing it in its exponential form. Okay, now, what is 10 to the 5th divided by 4? 10 to the 5th divided by 4. X equals 25,000. And that's your answer. Nice. Yes?
Well, you can just, like, you always put 10 as the base.
10 is the base, yeah. If there's no base, see it has no base, 10 is automatically it.
Oh, okay.
Yeah, it's called a common log. So common, so basic. Number 3. All right, let's try another one. 4 log of 4x equals 2. Okay, this one also, before you do anything else, you have to isolate the log. So right now there's a 4 in front, and you could bring that 4 up top, but that's just going to make it harder. Let's just divide both sides by 4, okay? So start by dividing by 4. I'm not dividing by this inside 4, I'm dividing by this outside one. So I get log of 4x is equal to 1/2. All right, don't get stuck right here. Here's where people get stuck. They get confused, like, where do I go now? How do I get rid of that log? Write it in its exponential form. What would this look like in its exponential form? 10 to the 1/2 equals 4x. Perfect. All right, so there's this 10 here to the 1/2 equals 4x. And then the rest is just to solve it, okay? So we'll go 10 to the 1/2 on our calculator. Yeah, you'll need your calculator. So good. 10 to the 1/2 is the same thing as taking the square root of 10. And then divide by 4. This one doesn't turn out as pretty as the last one, so x is approximately 0.7906. And that's your answer. All right, so those ones are on a scale of 1 to 10. Those are easy ones. Those are about a 2, maybe a 3.
Oh, you're lying.
Oh, no.
What's on the quiz? Like 2s, 3s?
Both, all of them, yeah. All right, number 4. Now we're going to have them where they're going to have more than one log. Okay, so something like this. Log of x plus log of 8 equals 3. Okay? So we haven't used that second step that we wrote down. Second step said to use your log properties to combine logs together. So the first thing you're going to do here is you want to get those logs together. They're both log base 10. We can rewrite this as one single log of what? Perfect, 8x. Right? We just wrote that yes, we just wrote that property down. Because this is plus, it turns into times. Equals 3. That's just the extra step. Now we're going to go ahead and write this in its exponential form. So the inverse of a log is exponents. So we're going to go 10 to the third equals 8x. Okay? And the rest you can do, in your calculator's fine. 10 to the third and then divide by 8. So x is 125. And check your answer if you want to. The log of 125 plus the log of 8. I hit equals, it equals 3. Yay, we did it right. Number 5. Only a few more to go. You can make it. All right, let's do this one now. Log of 5 minus log of 2x equals 2. Log 5 minus log 2x equals 2. Divide, yes. So we have a subtraction here. In between our logs, we're going to combine this into one single log of 5 over 2x. Is everyone okay with that step? Yeah, that's using our property that says minus turns into division. All right, so now let's rewrite this in our log form. They've all been base 10. It's kind of boring. Should do a different base. Usually they are base 10 though. So we'll go 10 to the second equals 5 over 2x. 10 to the second equals 5 over 2x. Now this is a little bit more complicated of an equation to solve here. So let's see if you remember how to solve something like this. 10 squared is 100 equals 5 over 2x. And do you remember how to solve something like this, what you can do? Cross multiply, yes. You learned this in, I think, Algebra 1. You can cross multiply there. And you get 100 times 2x is 200x. And 5 times 1 is 5. And then be careful. It feels like you should divide by 5, but you're not. You're dividing by 200. And you can write that as a decimal. 5 over 200 is exactly 0.025. Yes. All right, I'm going to let you try one now. You hate that part, don't you? Don't hate that part. Yeah. Yeah. All right, let's do log of 2x plus log of 5 is equal to 50. No, that's way too big. Way too big. Is equal to 5. All right, you try this one, okay? Try it all by yourself. You got this. So I'm going to combine this into one single log, and I get log of 2x times 5. So log of 10x equals 5. And now I'm going to rewrite this as 10 to the 5th equals 10x. I know that's the part where people mess up. Mess up. All right, so you end up getting 10 to the 4th, right? So 10 to the 5th divided by 10 gives you 10,000. Who got that? Good, good. Quite a few of you. Very good. Okay, the last two. Yeah.
How do you determine whether the base is 10 or not?
Oh, if there's no number at all, the base is automatically 10. We'll do one right now that has a different base. The last two are tricky. Math is your favorite subject. No. Said no one ever. Okay, here we go. I didn't like math when I was your age. I didn't. And I had a dad math teacher. Right there. Mm-hmm. No, he taught at Wilson High, and I went here. Yeah. So he was the math teacher, so I'd ask him for help, and there would be tears, lots of crying every night. Yeah.
My grandma was a math teacher.
Yes?
She was always like, oh, I'm sure you're doing great at math, right? Like, it runs our family. I'm like, yeah, I'm doing great.
So you lied to your grandma? That's terrible.
Well,
No, you're doing just fine. Yeah, my dad's dad was a math teacher. My dad was a math teacher. I'm a math teacher. Yeah. And I've tried to talk my kids. I said one of them has to do it, and they're both like, not it. So, but I told them. Yeah, but maybe her son. I'm like, no, I don't know. Okay, this one's tough. Here we go. But I did tell my kids, the 3 reasons why I started teaching: June, July, and August. So, all right, here we go. Let's rewrite this into 1 log of base 5. Okay? So we're going to take this 2. Now we haven't done this yet. We have to take this 2 and go over here. We can't divide everything by 2. I mean, I guess you could, but we're not going to. We're going to take the 2 and move it to the top, and you get x squared. And then on the bottom, because it's minus, it's going to be divided by 3. Is everyone okay? That involved 2 properties that time. Yeah. So the 2 is out front. It moves up, becomes an exponent right here on the x. And minus means divide. So I wrote it all in 1 log base 5. Don't write 2 log base 5s top and bottom. That's not right. Just 1 log base 5.
So why does it 2
how don't you divide by
Yeah, that was that property. You know that power to a power property when you have log of m to the n equals n times log m. I'm really doing this property backwards.
But you don't divide by 2, but
No, because you'd have to divide that by 2 and that by 2.
that's gross.
Yeah.
Wait, but so it doesn't cancel if you divide it by 2?
If you divided by 2 here, it would reduce out, but then you'd have to divide every single thing by 2. I guess that it would have been okay. It's, All right, so now we're going to take 5 to the 4th power equals x squared over 3. 5 to the 4th equals x squared over 3. And now we need to solve this, okay? So 5 to the 4th is 625. So 6, yes, and times 3 to both sides. So times 3, so we get 1875 equals x squared. Now, at this point, we're solving an equation. We have to take the plus and minus square root of 1875. Oh, the year I was born. 1875. Okay, so I end up getting plus and minus 43.3. Oops. Except there's one little problem here. The negative 43.3 is extraneous.
What is that?
Extraneous is I did everything right. Do you remember the word extraneous?
It's one of those solutions.
Yeah, it's a solution that is an extra solution. It doesn't work when you plug it back in. Try to plug in log base 5 of negative 43. It won't work. You're not allowed to take the log of a negative number. And so your only answer to this problem would just be 43.3. Just the positive. So a lot of you guys would have gotten this right because you actually would have forgotten to take the plus and minus square root of both sides.
Yeah.
And you would have gotten the positive and you would have gotten it right anyways. Which is like, erg, you did it wrong and you got it right. Cheating the system.
Oh, you just did it right.
Yes, I did it right. I don't do them all right. I did one wrong the other day. All right, number 8, here we go. Last one. Bless you. Last one. Okay. Suppose we have, this is the hardest one, okay? So if you haven't been paying attention, you might want to right now. Just because it's the hardest one, don't tune me out either. So log of x minus 3 plus the log of x is equal to 1. Yes. All right, so first step, we're going to combine into one single log. So this is the log of x times x minus 3. Is everyone okay with that step? I'm going to go really slowly on this one. Our first step is to get them into one single log. It's a plus in the middle, so I'm going to take x minus 3 times x and write it together. All right, the next step is the one that, a lot of people get stuck on. We're going to go 10 to the 1 equals x times x minus 3. 10 to the 1 equals x times x minus 3. All right, so I get 10 equals x squared minus 3x. And now what we have here is we have a quadratic to solve. See this? Quadratic, it's squared. And we spent a lot of time solving quadratics. So we're going to subtract 10 to the other side to get x squared minus 3x minus 10 equals 0. And we learned in that chapter, we learned 5 ways to solve a quadratic. Do you remember them at all? Quadratic formula was one of them. What was that? Yeah, that's the quadratic formula, yeah. We also did graphing. Star method, yes. That would be what I would do. I would solve by factoring. Okay? Remember star method? You put a times c up top, negative 10, negative 3 in the bottom with a 1 and a 1. And then you ask yourself, what times what's negative 10 adds up to negative 3? Yes, some of you guys are really good at factoring. So then we get x minus 5, x plus 2. By the way, if you plan on taking Honors Advanced Math next year, we do all of factoring in one day, and we expect you to know how to do like all of it on that first day of school. It's crazy. People are like, what? And then a bunch of people drop. Okay, so then we get 2 answers from this. What would make this factor 0? 5. What would make this factor 0? Negative 2. And then you go back and you check to see if they're both going to work. Okay? Oh, look at this. If I plug in 5, I'm okay. I get the log of 2 and I get the log of 5. But if I plug in negative 2, I'm going to get the log of a negative number. And I can't have that. So that one's actually extraneous, and I get 1 answer for this problem. Okay, when 2 answers show up, something usually is wrong on these. All right.